Now we shall consider the binary products, that is binary products of C2v point group. What is that binary products means? If you express in terms of either x square, y square, z square, xz, yz, xy, it is called as binary products. That is binary products means you should multiply x into x, y into y, or z into z, as well as xz, yz and xy. That is, here I have shown a tabulated form, that is a tabulated form which includes a translation vectors, a rotation vectors, a binary products, that is binary products in terms of x square, y square, z square, or xz, yz and xy. That is, C2v point group is having 4 irreducible representations. What are the irreducible representation? A1 is one of the irreducible representations. Similarly, A2, B1, B2. You can write it in a short form, that is no need to by heart that one, no need to by heart that one. You can directly write A1, A2, B1 and B2. For A1 you should, A and B should have a unidimensional. Then if C2 is minus 1, then it is called as B, and C2 is plus 1, then it is called as A. If xz is that is a vertical plane, that is xz vertical plane is plus 1, means the very first vertical plane is plus 1, means that is xz vertical plane is plus 1, means then it is it carries a subscript of 1, minus 1 carries a subscript of 2. Because of that one, this is A1, this is A2, B1, B2. Next, translation vectors, that is along that you should write the translation, you should write the translation by using the metrics. You should write the translation vectors. Similarly, rotation also, it's having its own metrics. It can also be represented by rotational vectors. It can also be represented by rotational vectors. That is, for your rotation vectors, that is 1, 1, minus 1, minus 1 corresponds to along the z, 1, minus 1, 1, minus 1 corresponds rotation vectors along y, 1, minus 1, minus 1, 1 corresponds rotational vectors along the x direction. Similarly, in the earlier videos I have discussed about translation vectors also. 1, 1, 1, 1, it corresponds to translation vector z. Similarly, 1, minus 1, 1, minus 1 correspond to translation vectors x. 1, minus 1, minus 1, 1 corresponds to translation vectors y. Now I should discuss about your binary products. Binary products means you should multiply x into x, y into y, z into z, or x into y, y into z, or z x into z. That is, this is nothing but it is commutative, nothing to worry. That is, it is a commutative law will be valid here, x square. Now I should choose an x, that is b1 I should choose, that is b1. That is, what are the x means? It is nothing but a b1. Nothing to worry about r now. I'm concerned about the translation vectors. I'm concerned about the translation vectors, that is x. X into x, that is x into x is nothing but x square. That is, I can write 1 into 1 for E, minus 1 into minus 1 for C2, xz 1 into 1, minus 1 into minus 1. That is, I should take this B1, that is irreducible representation B1. I should multiply 2 times. I should multiply 2 times. Similarly, y square. If I choose y square, what happens? I should choose B2. I should choose B2. That is, B2 is nothing but 1 into 1, minus 1 into minus 1, minus 1 into minus 1, that is this one, 1 into 1. That is initially the x square corresponds to A1. How it corresponds to A1 means 1, 1, 1, 1. That is, all are symmetric. That is A1. Similarly, this is also A1. Z square. If we come to Z square, I should use a translation along the Z axis. Translation along the Z axis. That is 1 into 1, 1 into 1, 1 into 1, 1 into 1. That is Z square. It corresponds to A1. It corresponds to A1. Similarly, xz. Xz means x is multiplied with the z. X is multiplied with the z. X is multiplied with the z means I should multiply 1 into 1, 1 into minus 1, 1 into 1, 1 into this one. This we get this one. That is, it corresponds to B1. Similarly, yz. Y is multiplied with the z. Y is multiplied with the 1 into 1, 1 into minus 1, 1 into minus 1, 1 into 1. That is corresponds to B2. And finally, if we come to xy, xy is nothing but multiplication of x with a y, that is 1 into 1 minus 1 into minus 1, 1 into minus 1 minus 1 into 1, that is 1 1 minus 1 minus 1. It corresponds to A2, irreducible representation A2. Now I should tabulate that one, that is A1 is nothing but x square y square z square, x square y square z square. B1 is nothing but xz, B1 is nothing but xz, B2 is nothing but yz, B2 is nothing but yz, A2 is nothing but xy, A2 is nothing but xy. This is with reference to the translation, binary products. Binary products should be expressed in terms of x square, y square, z square, xz, yz and xy.